Hey you guys, this is 5.2 Points of Concurrency. Little geometry joke there to begin. Alright, so on Friday we learned about angle bisectors, perpendicular bisectors, altitudes, and medians. Now we are going to learn what all three of those points look like when they meet for a triangle. So we got a question mark here for the three medians, but we'll fill that in on the next one. But here's what they all look like. If you have three angle bisectors that all meet together, if you have three perpendicular bisectors that meet together, and three altitudes, and three medians. Let's move on. Okay, so it's important to remember that perpendicular bisectors, where three of them meet, is the circumcenter. Where three angle bisectors meet, that is the incenter. And then where three medians meet is called the centroid, and where three altitudes meet is the orthocenter. Alright, let's move on to see each one's definition. Alright, so an orthocenter, the point of concurrency where three altitudes meet. Very important, orthocenter and altitudes. The next one is circumcenter, the points of concurrency of a triangle's three perpendicular bisectors. Now here's the theorem that goes with it. The circumcenter of a triangle is equidistant from the vertices of the triangle. So if you look, PA equals PB, which equals PC. Now we're going to try that out. Okay, here I have the theorem up top, but here's the example. DG, EG, and FG are all perpendicular bisectors. So they have some questions. They want you to find GC, but we need to know that G is the circumcenter. It's the circumcenter. It's where all the perpendicular bisectors meet. Now, BG, I'm going to write down here, BG, they tell us, is 13.4. Therefore, because of the theorem up here, we know that BG and GC are the same length. So GC is also 13.4. Okay, let's move on. So here's the incenter. This is the point of concurrency where the three angle bisectors meet. Now the incenter theorem is a little bit different. It's equidistant from the sides. Perpendicular bisector was the angles. So PX equals PY, which equals PZ. Let's try out a few examples. Okay, so here's the incenter theorem up at the top. And we have our example right here. It says MP and LP are angle bisectors of triangle LMN. Find each measure. Now part A, it says the distance from P to N. Well, P is the incenter of triangle LMN. And we know this by the incenter theorem, which is right above, we know that P is equidistant from the sides of triangle LMN. Now the distance from P to segment ML, which is right here, and they tell us that is 5. So the distance from P to MN, when we make a right angle, we know that is equidistant for all the points, as seen up here where I just circled. We know all those are the same. So the distance from P to segment MN is also 5. Alright, let's move on to the last one. Okay, so this is the centroid. This is the tricky one. It is the point of concurrency for three medians, centroid medians. And the centroid is very special because all of the points from P, like B to Z, if that is, let's say, 12, BP is 2/3 of that, so that would be 8. And then B to Z would be 1/3, which is 4, if the whole thing is 12. So let's go ahead and try that out in an example. Okay, here's our last example. In triangle LMN, RL, this whole thing, is 21, and SQ is 4. Alright, so let's look at part A. We want to find LS. Well, LS is 2/3 of RL. We know this from the centroid theorem. This is kind of our work here, and this is how we know over on this side. So RL we know is 21, so it's really 2/3 of 21. So we substitute 21 in for RL. And so 2/3 times 21 is 14. So this is how much LS is, 14. Alright, let me change colors. Now we're going to do the same thing here. We got what we're doing and the reasons for it. So we know NQ equals 3 times time for lunch. Alright, so we know NQ equals 3 times SQ. We know this from the centroid theorem. Alright, so we know SQ from up here. We know SQ is 4, so it's going to be 3 times 4. So we're going to substitute 4 in for SQ. So 3 times 4 is just 12. So NQ is 12. And how we did that? We just simplify. Alright, make sure you copy down all these examples, bring them in on Monday. We are going to get plenty of practice on Monday. Alright, so bring any questions and have your notes ready. Have a good weekend.